Welcome to the DIY Honda Garage channel. The DTC P2251 indicates an issue specifically related to the air-fuel ratio AF sensor 1's VS circuit showing high voltage. This code is stored when the powertrain control module, PCM, detects an open circuit condition in the VS line, which is crucial for ensuring the AF sensor functions correctly. The AF sensor is located typically in the exhaust manifold area, where it measures the ratio of air to fuel, providing critical data for engine management. The PCM, responsible for the engine's operational performance, relies on this information to optimize fuel injection and maintain emission standards. When the VS circuit experiences high voltage, it represents an abnormality, suggesting that the sensor may be malfunctioning, or there may be an issue with the linked wiring or connectors. It is crucial to follow systematic troubleshooting guidelines to isolate and rectify the problem in a timely manner. The DTC P2251 indicates a malfunction regarding the air-fuel ratio AF sensor, sensor 1, specifically concerning the voltage signal VS circuit. The AF sensor is critical for measuring the composition of the exhaust gases, providing data to the PCM, which in turn adjusts the fuel mixture to ensure optimal engine performance and reduced emissions. Typically located near the exhaust manifold, this sensor consists of multiple wires connected to the PCM. The PCM is the onboard computer that controls various engine functions, relying heavily on input from sensors like the AF sensor. When the VS circuit indicates high voltage, it can mean that the PCM has detected an inconsistency, leading it to store the DTC for further diagnosis. Understanding the roles of these components is essential for effective troubleshooting and repair. The potential causes of DTC P2251 involve several factors that can impair the performance of the air-fuel ratio AF sensor, sensor 1. An open wire in the VS circuit is a primary concern. This could result from physical damage, corrosion, or faulty connections, preventing proper signal transmission. Another potential cause is a faulty AF sensor itself, which may arise from age, environmental factors, or manufacturing defects, leading to incorrect voltage readings. Moreover, a malfunctioning powertrain control module, PCM, could also be at fault, where internal failures may cause misinterpretations of sensor data and improper control of engine functions. Identifying these issues is crucial for restoring the vehicle's performance to optimal levels. The symptoms associated with DTC P2251 can provide insight into the underlying issues affecting vehicle performance. A common symptom is the illumination of the check engine light, which alerts the driver of potential engine problems. Additionally, drivers may notice poor fuel economy, as the PCM may struggle to adjust fuel delivery accurately due to faulty input from the A-factor sensor. This miscalibration could also result in increased emissions, as the engine may run rich or lean, failing to meet regulatory standards. Recognizing these symptoms is vital, as they may indicate ongoing issues that could lead to further engine complications if left unaddressed. The first troubleshooting step involves starting the engine and holding it at 3,000 revolutions per minute (RPM) without load. This process is meant to gauge the operational status of the A/F sensor, sensor 1, under simulated conditions. The engine should be in either park, P, or neutral, N, during this procedure, allowing for a controlled environment. While maintaining the engine speed, you will observe when the radiator fan engages, which generally indicates that the engine has reached optimal operating temperature. Once the fan activates, reduce the throttle, letting the engine return to an idle state. This initial test helps in confirming whether or not the system is functioning normally and allows you to proceed with subsequent inspections. Next, you will conduct a thorough inspection of the VS circuit wiring to determine if there are any open circuits present. This involves disconnecting the AF sensor, sensor 1 connector, which typically has 6 pins, and the PCM connector, which usually consists of 80 pins. After ensuring that these connections are detached, measure the resistance across the female terminals of the AF sensor connector while the ignition is in the on mode. Ideally, the resistance should be less than 1 ohm. If the resistance exceeds this value, there is likely a problem in the wiring or terminal connections of the VS circuit. Confirming the integrity of the wiring is essential for ensuring that accurate data is transmitted back to the PCM. In the third step, make sure to verify the conditions set during previous inspections, and then focus on the PCM. The AF sensor, sensor 1, connector needs to remain disconnected while performing this inspection. The next action is to run the engine, allowing it to reach operational conditions, and checking the voltage output from the AF sensor. Normally, the output voltage should be around 0.2 volts or more when the engine is running. This voltage measurement is crucial as it reflects the sensor's ability to generate the necessary signals communicated to the PCM. If an abnormal voltage reading occurs, it indicates an issue with the PCM itself, which may need further diagnosis or even replacement. The final troubleshooting step focuses on the AFAT sensor, sensor 1, if all previous inspections reveal normal conditions. This follows a logical deduction where, if the wiring and PCM are functioning correctly, the AFAT sensor itself may be the root of the problem. To conduct the final inspection, ensure that all connectors are properly reattached and observe real-time data that reflects the functioning of the AFAT sensor. If abnormalities persist, it will confirm a malfunction within the AFAT sensor, requiring either calibration or replacement based on the diagnostic findings. The goal is to ensure that the AFAT sensor reliably provides accurate data for the PCM to optimize fuel management and emissions. Once troubleshooting and potential repairs have been completed, it is essential to verify that the repair was successful. Begin this process by clearing the diagnostic trouble code DTC P2251 using a suitable diagnostic tool. Following this, conduct a test drive under various driving conditions to monitor vehicle performance and ensure that the AF sensor is functioning correctly. After the test drive, recheck for any recurrences of the DTC or symptoms associated with it. Confirming that no additional warning lights illuminate and the vehicle operates optimally would validate that the repair efforts were effective. This step is crucial for overall vehicle reliability and performance. Preventive maintenance is vital in ensuring that components such as the AF sensor operate efficiently and effectively over time. Regular inspections of the AF sensor and its wiring should be performed to identify any signs of wear, damage, or corrosion, which could impede performance. Checking the integrity of electrical connections helps eliminate potential issues before they escalate into more significant problems. Additionally, monitoring engine performance through periodic diagnostic checks enables the early detection of discrepancies, allowing for timely resolution. Establishing a routine that incorporates these practices will help maintain vehicle performance and prolong the lifespan of critical engine components. In conclusion, understanding DTC P2251 and its implications on the Honda CR-V is fundamental for effective vehicle management. Recognizing the specific roles of components such as the A-factor sensor and the PCM is crucial in diagnosing and troubleshooting issues accurately. By following a systematic approach to troubleshooting, it becomes easier to identify the root cause of the problem, whether it lies within the wiring, the PCM, or the sensor itself. Moreover, incorporating preventive maintenance ensures that the sensor functions efficiently, reducing the likelihood of future issues. Adequately maintaining these components will not only restore performance, but also ensure compliance with safety and emission standards presented by automotive regulations. Please like and subscribe to the channel. See you next time.